Hello, students, and anyone else who may be watching from home. This is Mr. Borges, also known as Zanzolo, and today we're going to be starting our next project in Scratch, and this one is for Pi Day. Now, Pi Day is going to be, it's tomorrow for me. It's going to be yesterday once we're actually having the assignment. Sometimes Pi Day happens on the weekend. It's not a school day this year for March 14th. Well, we're going to do our next project in honor of Pi Day for our Pi project. So you see we have a new button right here labeled Pi. We're going to go ahead and click that one. So this media comment right here will read this page out loud for you if you click it. So this is the start of a new module. You can wait until we talk about this assignment in Zoom. So let's start our next Scratch project. For Pi Day, which was on March 14th, we will make a project that solves a math problem. We watched the video below together in class. Now, if you weren't here that day, you're going to watch this video on your own before you continue. The video below that, this video right here, which is the one I'm recording right now, explains everything that we did from the lesson in Zoom. If you don't know what you're doing, watch the videos. Okay, so you're going to make your own Scratch project that estimates the value of pi. Now, kids learn in school, even when they're much younger than you, that they use a value of 3.14 for pi. But you should have also learned that pi is actually an irrational number and that nobody knows the exact value of pi because it never ends. It actually goes on and on and on forever with no pattern and no repeats. And so because of that, we've got supercomputers that can know what pi is, can know millions of digits of pi, but there's always more and more and more that we don't know. So what we're going to do is we're going to estimate the value of pi. Yeah, you can look it up in a book to 10 digits or 15 digits or 20 digits, but all right, you're always just looking it up that way. There are ways that you can find pi on your own. And that's what this video talks about. So there's a Physics Girl video right here that you should have already watched. So I just want to talk about some of that Physics Girl video, and then we're going to make our own Scratch project that simulates this idea of what Physics Girl was doing in real life here. So what I'm going to do is, and you should have already watched this project. So here's this video. So here's Physics Girl, and she's talking about what it is that she's trying to do, right? So she's trying to estimate pi by using this target that she has and by throwing darts at this target. So you can see she's got a circle. She explained this in the video. She's got a circle. It's the same size as the square. Fits exactly perfectly inside. And the idea is that if you just randomly throw darts at this target, which is what she does in the video, that some of the darts are going to hit the circle and some of them are going to hit the whole square. The square and the circle's inside the square. But some will count as hitting the circle and some will count as hitting the square. Right? And so that we could keep track of those. And if it's really, really random, and what she describes here with a little bit of math, what she's saying is, if it's really, really random, then the ratio, the relationship between how many go in the circle and how many go in the square, if it's really, really random, that relationship is only just going to depend on how big the circle was compared to how big the square was. And so that relationship we know, right? It's the area of the circle, which is something that we could find, divided, and the relationship would be the area of the circle divided by the area of the square. So that ratio, that relationship, would be the same if it was truly random and you threw enough darts, would be the same as the relationship between how many dart hits went in the circle versus how many dart hits went in the total square. And that's the big idea of what Physics Girl is talking about. So that if you could then throw them randomly enough, right, so how does that help you find pi? Well, if one side of the square, Physics Girl explains this, she says if one side of the square is 1, say it's 1 foot, then the area of the square is going to be the length times the width. It's going to be 1 times 1. 1 times 1 is just 1. So she puts that in here. Then the area of the circle is going to be pi r squared. So the radius is going to be half of a foot. So the radius then would be pi times r squared, which would be 1/2 squared. 1/2 times 1/2 is going to be 1/4. So pi times 1/4, that's where she gets pi over 4, right? So that's where this pi over 4 comes from. Then she's just doing the division. She says, okay, pi over 4 divided by 1 is just going to be pi over 4. Okay, that's where that comes from. Then what she's saying is, because this relationship, the number of hits in the circle to the total square, is going to have exactly to do with how big the circle is compared to the total square, then what she does is she sticks this into her equation instead of that. The reason why is because she's trying to find a way to find pi without knowing what pi is already. So that's why she makes this next step right here. And then what she's going to do to find pi, we're basically solving an algebraic equation. To solve this for pi, she's going to multiply both sides by 4. When she does that, we can find then that pi is going to be equal to, if it's truly random and we throw enough darts, it's going to be equal to the total hits inside the circle divided by the total hits inside the target, which is square-shaped, times 4. And that's where the times 4 comes from. Right? And that would give us a value of pi. But this only works then if your throws are truly random. Now, the rest of the video are issues that come up with that, right? Where Physics Girl's talking about, well, they're people throwing darts at a target. How random is it? As you can see, yeah, there's a lot of hits all mixed up over here, but towards the edge, there was hardly any. Well, that's because they're people, and people throwing darts at targets are tending to hit their targets. That's not really randomness. So they tried to do, that was what they did the whole second day. So here they are the whole second day trying so hard to be more random, throwing behind the head shots, blindfold shots, right-handed, left-handed shots, doing everything that they can do, turning the target up on its side, all kinds of things they can do to try to be more random. Or to try to have the results be more random. And that included that their target was facing backwards. They drew the target on the other side of this, and they don't even know, Physics Girl doesn't even know where the target is on the back of that. So she can't be trying to hit it on purpose. It adds a lot of randomness. When they did this randomly, they got a value of pi that was much, much, much closer to the accepted value of pi. And you can see here, or you should remember from the video, that and I know it's hard to see because it's so small, but they end up getting 3.139. When the accepted value of pi is 3.1415. So, 139 when they would have gotten 141. So they actually got really, 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 really close by doing it this way. But the trick of what made it all happen, what made it work much better towards the end, was the randomness. So the good news for us then, we're going to do something like this. We're going to have Scratch do it. We're going to simulate what it was that they were doing. And the good news is that Scratch can simulate zillions. We can simulate 1 million random dart throws in a matter of seconds. That's the kind of thing computers are really, really good at. So here, I'm going to go ahead and start this project. What you can see is here's circle. I've got a circle sprite that I made. You're going to make your own. Here's the square sprite that I've made. And I've made them so that they're the same size, as you can see. Then what I do is I've got a little tiny, tiny, tiny speck sprite, another sprite, and it's in a forever loop telling it to go to a random place. So it's going to go to a random place and then use stamp to make a stamp of itself. And it's going to do that over and over and over and over. And then every time it does a stamp, I'm going to check if it's touching the circle, I'm going to count that. And then if it's touching the square, I'm going to count that. And we're going to count those up. We're going to count our circle hits. We're going to count our square hits. So I'm going to go ahead and click the green flag so you can see how that works. So I'm throwing darts, randomly sending that dart to a different position. And you can see, that we're getting, we've got about 150 square hits so far, and it keeps counting up hits, And it's doing the division. Circle hits divided by square hits and multiplying by 4 to give us an estimate of pi. Right now it's giving 3.24 for pi. That's not that good, but as you can see, it's going to get better and better the more and more darts that we throw. And this is an example of where using turbo mode in your Scratch project can be really handy. So I'm going to hold down Shift while I click the green flag, and it's going to send the project into turbo mode where it's going to just continue doing this as fast as it possibly can. So you can see it's sped up quite a bit. And then we're coming up with a value that's getting much closer to pi, So in this case, it's looking like 3.16, right? Which is a little bit off, but it also has to do with, I happen to know from ahead of time, it has to do a little bit with this being squished. This right now is squished into this window. If we go ahead and kick this into, which is too bad that it happens, if we kick it into full screen, and then I'm going to go ahead and do a shift click so we can get a turbo mode out of this, we can get a little bit better value when things aren't squished down. So as you can see, we're coming up with a value that's pretty darn close, right? 3.14 would have been 3.141 would have been our ideal, and we're getting pretty darn close to that. Now it's going to throw 1 million darts, and it's almost done with that now. And when it finishes up, you'll see that our number is pretty darn close. So why didn't I get exactly 3.1415926, blah, 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 blah? Well, it's because, right, my circle wasn't perfect. My square wasn't perfect. The dart that I'm throwing wasn't infinitely small. And there's issues with, whether or not computers can truly be perfectly random or not, because they can be pretty random, but they're not perfectly truly random either. And so there are other reasons why we're not getting exactly pi, but this is a pretty darn good approximation of pi, right? And so what we're going to do is we're going to create our own project that uses this exact idea. So I'm going to show you how we can simulate things. And doing a simulation of something that's in real life is a really useful thing that we can do with computers. Okay, so I'm going to go over the checklist of what it is that we're going to do in your project. So you're going to have a tiny sprite, that's the dart. It's going to go to random locations and stamp 1 million times. I want to see 1 million times in your project. That's the idea, right? Then we're going to have a circle sprite and a square sprite. And the circle should fit exactly as best that you can make it inside the square, just like in Physics Girl's target. Okay, then number 3, you're going to have 2 variables. You need to reset them both, and they're going to keep track of how many dart hits you got. One count the circle hits and one counting the square hits. Okay, then when you're done, you're going to calculate pi by using the formula, the same formula Physics Girl uses. Circle hits divided by square hits. It's the same exact formula that she's talking about right here. Right, so it's going to be the circle hits, right, this number of circle hits divided by the total hits on the target, the square hits, and that's multiplied by 4. And that's what's going to give us our value of pi. And then, of course, you're going to get yourself a better title than untitled, some instructions, and submit your project to Canvas. Okay, so I already know that even those of you with the most experience with pi maybe are going to have to refer to the example and watch my video if you need more help with making this project, and that's fine. Please do watch this video over again, pause, fast forward, and rewind, or refer to the example that I made. Okay, so we're not using Scratchcat for this one. We are going to need, though, those sprites that I talked about. So I'm going to I'm going to paint my own circle sprite, pick a color for it. I don't need a outline for it. What I'm going to do is I'm going to hold down Shift. If I don't hold down Shift, see, I get like whatever squished ovals or whatever else. But while I'm making the circle, if I hold down Shift, I get a nice circle. So I'm going to go for something kind of big that mostly fills it in. I'm going to move the center so it's snaps onto the center of the project. And then there we go, of the artwork. Now you can see it's not on the center here. That's only because my sprite's not centered. So what I'm going to do is just one time to put it in the right place, I'm going to send it to 0, 0, and then click this. There, now you can see my circle is exactly in the middle. Now what I'm going to do is I'm going to create a new sprite. This one's going to be the square. Go ahead and pick out a different color for yourself. Doesn't matter that much. And I'm going to get the square tool. I also don't want an outline on this one, and I'm shooting for making this the same size. Now, that's not a square. It's all squished rectangle unless I hold down Shift while I'm doing this. So you're going to hold down Shift while you're doing this. Now, when I let go, I want it to be close to where I'm supposed to go. I'm not moving it over here, you guys. I'm moving it over here. Make sure it's right on the target. Okay, and then we're going to send it to the middle in the same way. We're going to send it to 0, 0. There we go. Now you can already see that my circle is either too big or my square is either too small, however you want to think about it. Now what I'm going to do is I'm going to switch the layering. So I'm going to click on the circle. I want the circle to go to the front. So I'm going to go to looks. I'm going to get this go to front block. And then I'm going to click it one time to move it to the front. Now we're going to have to adjust the circle. Circle's a little bit too big. Let's just try to make it 99 instead of 100%. That still seems a little bit too big. We're going to go for 97 maybe. That seems pretty darn good. Check 96. Maybe that's it. I think that's it for us, right? So you can see then now that the circle, the distance across the circle is the same as the distance across the square, right? That's what we're going for, right? So if you get to where 95 seems too small and 96 seems too big, you may have to redraw your circle to get one that you can adjust to be right where you want. But that usually works the way that I just did that. So now we need a dart. A dart, we're just talking about keeping track of the dart hole, the little pinprick that the dart makes in our target. So I'm going to draw a new target, and I'm going to grab the tool. I'm going to zoom way in, and what we're going to do is, I don't know, make this one black or some dark color if you want. And then what we're going to do is I'm going to make this pen size smaller. That's maybe too small. And then something like this. And then I'm going to draw right there. Now I'm going to move it the same I moved those others. I'm going to go ahead and zoom in some more. I'm going to move this so that it's on the center. So I'm moving it right there so it snaps into center. Make sure that you can still see it over here. If you can't see it on the stage at all, it's too small, and you're not going to be able to see when you're stamping with your dart. That's where our dart pin prick is going to be on the target. So now what we're going to do is, right, we're not keeping track of anything yet. We're just seeing what we want to do. What we want to do is we want to be able to, over and over, but not forever, right? A bunch of times. We'll start out with just 10. Eventually, we're going to go to 1,000,000. We want to send the dart to a random position. And then keep track of where it went. So we're going to have it do a stamp. And to do that, we're going to add the extension for pen blocks, and we're going to get out a stamp. That's the big idea. Right? So now if we run this, we're going to get 10 random stamps. Right? And then we want to erase all in between. And then every time we do this, 10 more random stamps. 10 more random stamps. 10 more random stamps. Right? There we go. So part of what's going on, and you may notice this, is that any stamps that are happening underneath our sprites, we can't see them. Right? There's stamps that are happening underneath our square and underneath our circle, and we cannot see them. I want to be able to see them. I want you to be able to see them. So what we're going to do is we're going to get a ghosting effect for our sprites. We're going to change the ghost effect. And you can play around with this. I don't know, around 75 seemed to work for me. And then we're going to stick it there. And I'm going to do the same thing then for the square. I'm going to change the ghost effect. Whoops, I want to set it. I want it to always be the same every time. I'm going to set the ghost effect to be 75. Did I do set for this? Now let's fix this. Set. We want it to be the same every time. We don't want to keep changing by 75 every time. Set your ghost effect to 75. So I'm going to set it. I'm going to go ahead and, when the green flag is clicked for both of these, there we go. So they're always going to be in the middle. They're always going to adjust their ghost effect. And now we can see through. Now we can see through these shapes, and we can see that we were getting other dart hits that were underneath them, but we couldn't see them before. So now we can see all of our dart hits. That's the big idea. So we're only doing 10 dart hits at a time, but there's nothing to stop us, right? When we're ready, here I'll just do 100. When we're ready, we're going to be able to do 1,000,000. All right, so that's the big idea. So now we can do 100 dart hits. Now what we need to do is, for our dart, while we're doing these dart hits, we need to check and keep track of, did the dart hit the circle? Did the dart hit the square? And we can use if blocks to check if they're touching. So the dart's going to go to a random position. Yeah, it's going to stamp itself, and then we're going to check if two things are happening. Now we're going to need two counters to keep track of that. We're going to need a counter to count circle hits, and we're going to need another counter to keep track of square hits. Those are going to be our two variables that we're keeping track of. And now we're going to check each time we go through our repeat loop. We're going to be, go to a random position, do a stamp, and then check if touching circle. Now let's rename these sprites so that we don't get mixed up later. So that's my circle sprite. Whoopsie, what am I doing? That's my circle sprite, and then here is my square sprite, and I'm just going to rename this sprite also while we're here. This is my dart. So if we're running code for the dart, so go to a random place, do a stamp, and then check if you're touching the circle. We're going to count that. So we're going to change the circle hits by 1. So we can keep track of that. And I'm going to duplicate this. We're going to do the same thing. If you're touching the square, change the square hits by 1. So we're going to be able to keep track of how many circle hits we have and how many square hits we have. Okay, so there we go. So we can run this, and you can see that it is counting those. Now we should get more square hits than circle hits. We would expect that because the square is a bigger target. And you can see if we do it again, these numbers didn't reset. They just kept going and going and going and going. I want these numbers to reset every time. So when the green flag gets clicked, we need to reset them. We're going to set circle hits to 0. We're going to set square hits to 0 every time we click the green flag. Then we're going to erase all the old dart marks. Then we're going to repeat going to a random position, doing a stamp, and then checking if it's touching circle, if it's touching square, and counting those up. So that's the big idea. Then what we're going to do, just like Physics Girl did in her project, we need to keep track of some way of keeping track of at the end. So we can use my variable for this. I'm going to make another variable for this. I'm just going to call it pi. And so what's pi going to be? Well, after we do our repeats, at the end of that, we're going to set pi. We're going to set pi to this equation that Physics Girl is talking about in her video, right? We're going to take the number of circle hits divided by the total hits of the square and multiply that by 4. And that's the big idea. So we're going to do the same calculation that she was doing. So under operators, we're going to get this division block out here, and we're going to divide those two things. So it was circle hits divided by square hits. And then we need to take this whole thing and multiply it. So we need another math block. We need to take that whole thing then and then multiply that times 4. That's the big idea. So then we can do something with this. Yeah, we can set it to a variable pi so that we can then, here I'll double click this to make it bigger, so then we can get a value for that as we go. So we go ahead and run this and we can check it out. Now the way I have it set, it's going to go through the whole thing, and when it's finished, it's going to do the whole repeat, and when it's finished, it's going to calculate pi one time at the end. We can actually have it calculate pi inside the loop every time as it goes, and we're going to be able to see pi change over time, right, as we get better and better. So 3.12 is what we got, right? And that is kind of consistent. That's actually a lot better than the crummy values that Physics Girl was getting at first, partly because our project is way more random than hers was. But even still, you can see, right, there's time over here, we're only getting one dart hit in this whole corner over here, right? So does that seem random? Well, I don't know. It's hard to see randomness. But what we can do now is, now we can add more. So we can go for 1,000 and run that. And already that's going to start taking longer than we want to sit around and watch it for. So we're going to do our shift click. I'm going to hold down shift and click the target, and that gets us into turbo mode. So you can see now we can go way faster. And instead of just doing 1,000, we're going to go ahead and do 1,000,000 simulations, right? 1,000,000. 1,000,000 dart throws. And the computers are really good at doing things fast. Computer's going to be able to do 1,000,000 dart throws in just a few seconds. All right. And then there we are. So coming up with more and more and more random throws for our project. Now, did we get exactly 3.14? No, we didn't, right? And that's normal. Actually, you shouldn't expect to get a perfect value for this, partly because, right, of things we talked about before. Was our circle exactly perfect? Maybe, maybe not. So one way that we can adjust that, make sure that your circle and square are the exact same size, is by, if we go to our square. Now, when I first drew this square, I wasn't very careful about exactly what size it is, but you can see the square is 325. I came back and I tried to draw another square. Let's just draw another square right now. So we're going to draw another square, paint another sprite. I'm going to choose a square. I'm going to hold down shift so that we get a nice square here. And then for this one, I think we're making our square this color. And then, yeah, you can grab your selection tool, put this square right at the center. And then over here, it's showing you. You see where it says 299 by 299, right? I'm going to adjust carefully, patiently. I'm going to adjust my square to be a tiny little bit better. Now you see it's 300 by 300. Okay, so I'm going to use that as, I'm going to delete these other sprites, costumes. So 300 by 300 is the size of my square. I'm going to go to my circle now, and I'm going to go ahead and delete these other costumes here. I'm going to paint a new costume. I'm going to choose a circle. For this one, we're going to use this purplish color we're using here. And I'm going to hold down shift while I draw my circle. I'm going to put it right on the center. And I can see this one is 328 by 328. I'll get rid of this other one. So that's a little bit too big. It's not the same size as my square. My square is 300 by 300. I know that. So I'm going to reduce the size. See, 313 by 313 is too big. Reduce the size. 297 by 297. 301 by 301. 300 by 300. I'm going to make sure it's on center. There we go. So now I have a square that's 300 by 300 and a circle that's 300 by 300. So that when I run my code for 1 million simulations, I'm still in turbo mode. We hopefully will get a value that is a little bit closer to pi because we were more careful with making sure our square and our circle were exactly the same size. And here we're approaching a value. Remember, Physics Girl got 3.139 and it was high-fiving and was super excited about how close that was. Our value's a little further off, so maybe not quite as cool as Physics Girl. And maybe she got lucky, or maybe she was more careful than we were when she drew her shapes. Or maybe if she'd have thrown more darts, then she would have got a value closer to ours. But we're getting pretty close to what she got. So 3.136, and she got 3.139. So right, not a bad approximation for pi. Almost as cool as Physics Girl, right? Not quite. For your checklist, right? Make sure that you are doing 1 million simulations. That's what I want to see. You're going to have your circle and your square sprite. They should be the same size, the same distance across. Right? The diameter of your circle should be the same as the length and the width of your square. Okay, then you're going to have two variables to keep track of and reset, counting the circle hits and counting the square hits. And then you're going to calculate pi with that formula, the same formula that Physics Girl uses, circle hits divided by square hits times 4 to come up with an estimate for pi. Right? Get yourself a better title than untitled and some instructions. And of course you would do that, right? So I'm not even signed in right now, but you would definitely be signed in with your project. Get yourself a better title than untitled, Pi Day Darts or something, get yourself a better title, get yourself some instructions for the project. Just don't leave this blank. You'd click share. And then once you've done that, you would also, get some instructions. Happy Pi Day, click the flag, something like that, because I just don't want you to ever leave this blank. And then, you would copy the link, go back to Canvas, And then that's where you would then turn this project in. So you would click Submit Assignment here, paste your URL in of your project, and then click Submit Assignment. Make sure it's throwing candy like this and tells you that it's submitted. If it doesn't say submitted, if it doesn't throw confetti, then you're not actually done. All right, folks, so that's it for this one. Thanks for watching, and we'll see you next time. Bye.